Hi everyone, this video is going to help with proportional relationships and equations. This is section 2, 4, and 7th grade. And I've been seeing all these videos of all these people dancing while they're teaching and all these things. So I was thinking if I cracked out some dance moves, maybe you guys would like math better. I'll have to get a vote on that and see. Or maybe if I sing a song, let's see, instead of just teaching math, blah. So, what is the key concept for this section? Well, the idea is we're still talking about that constant of proportionality, which remember was just y divided by x on your charts, like your x and y numbers, your samples of x and y combinations. But this time I want to show you it in a little bit different way. That when we have a relationship between x and y is a constant multiple of x. So basically, which is a little confusing, let's look at this equation. When I have y equals mx, m would be where the number is. So you might have y equals 2x or 3x or 1/3 x or something like that. So what it's saying is m is that constant of proportionality. Another name for m would be the slope of something or the rate of something. So we talked about the rate being the constant of proportionality a little in the last section. But that really is what it is. Like, how many of one thing do you do per one of the other, right? So that is our constant of proportionality, still a rate, unit, whatever we want to call that thing. So let's look at this equation right here. Y equals 8.5x. So when I look at 8.5x, what is the constant of proportionality? What number relates y and x? 8.5. It's that easy. So don't make it harder. Whatever's in front of the x is your constant of proportionality. So, and they show here why it is that way, because we could divide by the x and we would have y over x equals that 8.5. So that you see, well, we know it's y over x. Why is it this random 8.5 in front of the x? Because I could solve, but that's, a little uglier, but hey, that still works. What does the constant of proportionality represent in this situation? Well, we know y is the cost in dollars and x is our movie tickets. So it's y over x. So it's the cost in dollar per movie ticket. So when they write that out, let's see, is $8.50 per ticket. So there's where they showed it. So it's the cost per ticket. So we always want to add that word per to that X value, which was tickets. Okay, let's see. How much will 13 movie tickets cost? Well, we know it's 8.5 that relates them. So really, we know that this is a movie ticket, which is X. We're really just putting that 13 in for X. And so we're timesing those together to get our 10.5, 110.5. And so the cost is $110.50 for 13 movie tickets. Okay. All right, let's do a couple other problems. Let's say, here's my, well, I think I'm going to show you this so that I don't have to write it out and mess it up. Okay, a certain vegetable dip contains 60 calories per serving. Hey, that's a unit. That's a rate. It's per serving. So 60 calories per serving. What equation represents the number of calories, y, in x servings of dip? So what was that 60? Oh, it was our rate, right? So when I go to do this, it's just going to be y, which was our calories, equals, and then we knew it was 60 calories per serving. So 60 calories per serving is per X. So this is our formula for that. Y equals 60 times X. And then you could, answer other questions on it if you needed to. All right, let's do one that's not per serving, so it's a little bit harder. So B here, a telethon. A volunteer can make 60 calls in 5 hours. What equation represents the number of calls Y a volunteer can make in X hours? Well, the problem is we don't have per one serving, so there's a couple ways we can do that one. Let's go back to our paper here. This is it was B, but whatever. Problem 2B. So we're going to let Y be the number of calls, the number of calls, and then X was equal to what was this one? Hours? Yeah. So we know what they meant especially because you can't see the question anymore. So one way to think of this is I have to get that rate of Y over X first, which we got an example. We were told 60 calls in 5 hours. And then I would have that M number, right? That rate that relates the Y and the X. So basically you just divide them and then you have your rate. So 60 divided by 5, for some reason I was thinking it wasn't 12. So it's 12. I was second guessing myself. Okay, so it's 12 calls per hour. That's how we would think of that. 12 calls per hour. So our number of calls is going to equal 12 times the hours, or I don't have to write the times. I can just write them next to each other. So we know there's 12 calls per hour. So however many hours times 12 will give me those calls. So all I did is find that rate by dividing Y and X, and then put that rate in being times by that X. All right, let's see. So you might be given a chart and you have to write an equation. Well, how would I do that? Okay, well, let's look at this example here. This one has $50 to euros. So if you've ever traveled, I don't get to travel much unless, driving up to the mountains is traveling. So here's our chart here. How can I write an equation that relates dollars to euros using this idea of a proportional relationship? Well, I got to find that M. What is the rate? What is my constant of proportionality? So we're going to look at just to the 50 and the 37.5, those first two numbers, and we could divide all three to make sure that it's proportional. But I'm just going to take the Y value is 37.5 euros, and to the $50 of the X value, and that was US dollars. And again, we could divide each of them, and you could use a calculator to divide them if you want to see quick to make sure they're all proportional. That's fine. So 37.5 divided by 50 is 0.75. So this is 0.75 euros per $1. Right? That's how I think of it. Euros per $1. How would I write the equation? Well, let's let Y equal which value? Euros. And let's let X equal the US dollars. Right? Because X was the first row and that was dollars. Y was the second row. That's our euros. And the relationship is 0.75. So I have 0.75 times X. And that's my formula. Or equation. Or function sometimes is what they're called. So any way that you can relate those two is great. The last thing I want to show you is how to use this idea of proportions and looking at a proportion. We've been looking at proportionality, but the word proportion typically is referred to or you compare two ratios, or you set up two fractions equal to each other. And so let's look at where we could use this idea. It's actually how I solve a lot of really harder questions. So I'm going to show you a problem here. A local soccer league, the ratio of goalies to the total number of players on a team is 2 to 30. If the league has 915 players, about how many goalies are there? So they give you the ratio of goalies to the total number of players on a team is 2 to 30. So let's look at how we can write that on in a proportion, how I'm thinking of it. So we know 2 is the number of goalies. And then 30 is the number of total players. I'll just call them players. That was our relationship, right? So I'm going to set that equal to what I'm looking for. So what I was looking for is the total league's goalies. So I don't know the goalies. So I'm going to use an X to show I don't know how many goalies are in that total league, but I do know there are 915 players. So I basically have goalies on the top, players on the bottom, right? The one that we knew the top and the bottom. We have to have one that we know both the top and the bottom. That's what gives us our ratio, our proportionality ratio, or our relationship between the two. And we know that that has to equal so many out of 915. So how do I solve this? Well, there's something called cross products, and it is by far the easiest way to solve a proportion. So let me show you. So we're just going to look at just the numbers. And we're going to do the cross products. 30 times x, we just write as 30x. Okay, we're lazy. We don't want to put a time symbol in there. And then we look at 915 times 2. That is 1,830. So I took these two by times each other and these two times each other, and I put an equal sign in between. Basically, we're timesing. We're doing that opposite operation. It just looks a little different when it's a fraction equal to a fraction or a proportion. And these are called proportions. If you need more help, you can Google proportion. So then from here, I divide by that 30. And I would have 61. So there are 61 goalies in the total league. All right. So another way to think of it is you could think of, well, 30 times what is 915? So this method that I just showed you works if you have fraction, decimals, ugly things, and so it is a great method to use. But I could take 915 and see how many did I times 30 by to get 915. I would have to times it by 30.5. I just divided. And I can times 2 by that 30.5 to get 61. So you can kind of play with the numbers when they're pretty and say, well, what did I times 30 by to get that 915? Okay, times the 2 by that same thing. And so you can kind of play with that proportionality without doing the cross multiplications if they're easy numbers. Okay, and then so you have a couple problems like that you solve, and then a couple charts, and you find a couple M's that proportionality. So hopefully you'll be able to solve the rest of the problems. Right. Next time I'll rock some dance moves.